So application of nanotechnology and self-cleaning. This has been the latest technology which a lot of paints and other materials are being worked on. Currently, what you are saying is the Jubilee Church in the Rome, and the speciality of this particular building is that it is being made by self-cleaning concrete and air purifying concrete. So there are a lot of nano materials like nano titanium dioxide and other. They have very different properties. When once we crush material to a nano level, then a lot of new properties are being found by the people. Okay, so as we know, the nano is 10 to minus 9 of a meter. What you are seeing is a hair of a human hair, basically human hair. Okay, and nano materials are, almost 80,000 smaller than a human hair. This is a typical human eye range, microscopic, because of the, scanning electron microscope and other microscope being invented. Okay, now people are able to see at the nano level and even higher than that. Okay, this is a typical instrument which is being used, okay, for seeing and measuring the things at nano level, scanning electron microscope. Okay, if you can see the ultra fine silica fume particle, it will look like this. This is a 50 nanometer, and a typical strength checking are also being done at nano indentation like this. So I was fortunate to utilize scanning electron microscope during my PhD at Indian Institute of Science, Bangalore, and really this is an upcoming thing, and a lot of new work being carried out at the nanotechnology level, right? So these are the few nano materials, directly, impacting our civil engineering and construction industry, like nano silica, a round particle like this. Okay, again, when I say nano, the scale will be 10 is to minus 9. Okay, and a lot of research has been shown that using nanomaterial is increasing the strength like anything. Okay, like one of the concrete called Gaia. Okay, one day it has shown one day strength of 68.2 megapascal and so on, right? So this can trigger a lot of interest in the young researchers to work on this particular area. As I mentioned about nano titanium dioxide TiO2, okay, the very first the very important some of the properties of this material is like it can break down the pollutant, and it has a self-cleaning ability also, right? So this particular church which I had shown in my first slide, okay, it actually cleans environment, at the same time it cleans at its own self-cleaning properties there. So it can never get shabby, right? Another important and beautiful material, promising material is the carbon nanotube. It can be single or multi-wall carbon nanotube, and if we check the strength aspect of the carbon nanotube, while the conventional steel which we are using, it has a Young's modulus of 208 gigapascal. Carbon nanotube has 1054. Conventional steel has a tensile strength of 1 gigapascal. Okay, whereas the carbon nanotube is 150, and you can see the density at the same time. Density is only 1.4 gram per centimeter cube. So we can say that carbon nanotube, this is a futuristic material I'm talking about, it is basically 150 times stronger and 6 times lighter. So it opens a lot of new opportunity for the construction industry. This is how typically it can be thought of a cantilever of such a large size, if it is futuristically made by carbon nanotubes. Coming to the self-cleaning property, like all our civil engineering structure are subjected to environmental effects. Okay, maybe freeze thaw, solvers, acid rain, fluorescences. Okay, but then studies have shown that if we coat it through some nanomaterials, okay, there won't be any efflorescences seen. Okay, also if you can see here like few examples, it can be shown that such kind of coating will be very much useful. Okay, because they have the the property called super hydrophobic, okay, layer. So that is also called as lotus leaf effect. There is a wax layer, nano wax layer, which actually doesn't allow the dirt particle to set on it. And whenever suppose there is a monsoon, okay, that water will actually take all those dirt and make it self-cleaning. Okay, so this is how some of the paints are these days also like having this property of self-cleaning, and those buildings will be always shining. Okay, glass also can be applicable to glass, and this is what I was trying to explain on that. This is the natural layer, okay, in terms of lotus leaf. And in case of our coatings, okay, we can provide through materials like nano titanium dioxide, okay, coating which will act as a self cleaning. Okay. Right, very similar. I think actually what will happen, dirt, if it is there, then by monsoon it will get cleared off, and that surface will be cleaned. Okay, I will skip this self-healing part because it is may not be the part of this particular this one, but yeah, application to concrete, like just as a maybe the last slide, materials in civil engineering. Okay, previously we were actually in the conventional range. Okay, now people have started using the high strength high performance concrete range, wherein the materials have gone to the silica fume, maybe micro layer, right? Something known as nano engineered concrete is a material wherein we use the materials ingredients which are at the nano silica or nano titanium dioxide, right? So this will actually provide more specific surface area and for the reaction to happen, and it will it can show a big good properties which are beneficial to civil engineering. Okay, this is a typical example of what we mean by specific surface area. Why nanomaterials behave in a different way? If a cube of 1 centimeter by 1 centimeter, 1 centimeter will have 6 centimeter square surface area. However, if we divide that into 1 cube, it will have 60 centimeter square surface area. But if we divide that into 1 nanometer cubes, then it will have large specific surface area, though the volume original volume remains the 3 centimeter cube. Okay. uh, yes, I think these are a few more studies, but maybe I would like to end my input.